Alright, had a tiny bit of technical difficulty, but here we go again. So, here's what it's going to look like. And now we'll draw this out the way it's really going to look. So, remember, we're pointing at the very bottom of the stack. Let's change this. Let's draw with yellow. Okay. So I'm going to pre-decrement my stack pointer by a double word. So I'm going to allocate 1, 2, 3, 4. Pre-decrement to right here. And I'm going to push 25. Now, I am pushing a multi-byte scalar value into memory. The runtime stack is memory. So I'm going to push it in reverse byte order. So what this is going to look like is 0, 0, 0, 0, 0, 0, 1, 9 hex. Okay? Same thing when I get to my second instruction. I'm going to push a double word, 1, 2, 3, 4. So I'm going to pre-decrement my stack pointer and push 10. 0, 0, 0, 0, 0, 0, 0, A on the top of the stack. So right now, stack pointer's right here. And then when we get ready to pop ESP, we will pop the double word. So remember, pop automatically is going to look at the destination for size. So this is going to pull a double word from what the stack pointer is pointing at. Well, here's the double word that the stack pointer is pointing at. So as a result, I'm going to copy into EAX the double word that the stack pointer was pointing at, which is going to be 0, 0, 0, 0, 0, 0, 0, A. And then I'm going to post increment my stack pointer. Okay? So, give you a little bit better idea of how that's going to work. Okay. This example we're actually going to kind of walk through right now. So what we're going to do is we're going to load the address of an array. Actually, what we want to do here is I want to count the number of values that are divisible by 5. So let's just talk about how this is going to look, and we'll kind of make some little design notes over here in my register area, okay, as we go. That way we can kind of track what we're doing. Okay, so load the address in the array. Normally we use EBX for that, so we'll go ahead and say that that's what we're going to do. So I'm using EBX. Initialize a countdown counter to max. It's a countdown counter in a decrementing count controlled loop. So I'm going to use ECX for that. Initialize the counter for the values divisible by 5. So I've got another counter. I'll keep that in EDX, because what I'm going to be doing is getting a value and then moving it to a scratch register. Well, EAX is my scratch register. The problem is right here. Whoops. What happens when we try to prepare for division? That's going to take whatever's in EAX and sign extend it into EAX EDX, but I'm already using EDX for my counter for the number of values divisible by 5. So what do? I can't use EDX here. My solution is use the runtime stack. So right here, and I'm going to erase everything. We'll go back and make some notes. So I'm using EBX, ECX, EDX, and EAX. So right here, before we prep for division, let's push EDX. Okay? That will push our counter on the stack. We can still prepare by division, divide it by 5. In that case, I've got my remainder in DX. my quotient in AX. I'm going to compare my remainder to 0 right here. And at that point, well, actually, right after we do this division by 5, after I compare the remainder, now I can pop EDX, and this will restore whatever that previous value was in EDX before we had to go and push it on the stack. So, kind of give you an idea how to do it. At this point, we're actually going to do what I told you we were going to do, and we're going to deviate. So, section 6.2 explains how to set up a function call with parameters if you're going to call an assembly language function from another piece of assembly language code. We'll get back to that and kind of cover the basics of it, but for now, what do we want to do? What we want to talk about is what is it going to take to set up a function call with parameters. Now we're going to pass parameters, unlike we did in assignment 7. We're going to pass parameters to an assembly language function with C++ calling code. So, what is it going to take? I think I mentioned this to you guys already. And this is regardless of the language, the level of the language, anything. A convention describes how the arguments are passed and then how the values are returned by functions. Okay? So remember, every time you call a function in C++, as C++ is compiled, it's compiled into machine language, and so therefore, we've looked at this in disassembly, C++ is also using those same registers, the stack, everything. So here's the deal. Before it hands control of execution to you, the function, what does it want to do to make sure the things it feels very strongly about are going to be saved so it can restore its status at some point? The calling convention is going to do that. We have to understand these if we are going to successfully link any high level with assembly language code. So, the one I'm going to show you is actually one of the C++ has, oh my goodness, so many different calling conventions. The one I'm going to show you is called __ declare spec, DECL SPEC. Okay, declare spec. So there's 5 steps when you're making a call from C++ to anything, and this is C++ to C++, C++ to any other language, whatever level. Okay. First thing, when the function is invoked, C++ will save necessary registers. And when we say necessary, what does it consider to be necessary? Well, it considers ESI, EDI, remember the source and destination index registers, EBX, since that's often used as a pointer, and my base pointer. So it's going to save those to the stack. This first step is called the function prologue. Okay, second step. If parameters are being passed, they will be passed in reverse order. That means if I've got 3 parameters, then the rightmost parameter in my list is the first one that's going to be pushed on the stack, followed by the next rightmost parameter, followed by the first one, if I have 3 parameters, for example. In the third step, the address of the next instruction, or the return address, which is, at this point, what is in EIP, is going to be pushed on the stack. This is how we know how to get back to the calling code, okay? This is important. Okay, fourth step is the address of the function will be placed in EIP. So function address copied to EIP, and we begin execution at that point, at the function. Okay. Fifth, the calling code. So whatever is calling this function will clean up the stack. So what that means is it's going to clean up everything it pushed on the stack. This is going to be important, but we'll come back to this after we've done a couple of examples to see exactly the details involved in this. Okay, so we're going to do a couple of examples. This is a good break point. Let's break here, and we'll come back and talk about, in fact, we're going to do a couple of examples, but we'll save those for class.